Hello, Mr. Borchardt. This is just a quick overview of what we do in biotech. Unit 1 is safety and documentation. It really is a science class of sorts. Very hands-on though, but being that it's a science class and in science, documentation is really critical. So there's a heavy emphasis on having all your notes in decent order, and saving everything over the course of your developing a portfolio. Portfolio will be the student's final exam, the high school final exam. They will be taking a final exam for the potential of getting college credit at University of Iowa. But for the high school final, it will be solely off their portfolio. So, part of that's going to be neatness organization, and I look at that kind of stuff throughout the year, making sure that their note taking is improving. I don't expect them to be experts right off the bat, but we work at that throughout the year. Unit 2, which is what we're on right now, is Intro to Biotech Engineering, and I've got this a little bit out of order. Right now we're working on researching companies, incubators, and university research. The focus is to follow the funding and how things evolve from being an idea at university to going to like an incubator where you've got just one product or two products to becoming a big company. Okay, so that's what we're doing there right now. Next I'm going to go bioethics, and we pick a real-life problem. Last year the students picked Frankenfish, which is this genetically modified salmon which grows like 5 times faster than a regular salmon, and there are some potential safety, health and safety issues, environmental health and safety issues that the company that was doing it didn't seem like they're doing a great job, and we learned all that by doing the research and figuring this out. So, so we do bioethics, and then we'll follow that up with researching the biotech history, like, okay, when was the first mechanical heart designed, and different things that would be considered biotech. You could look at something like a microscope. Well, that really is biotech. It helps us out, and who invented that? So students will be doing some research on that. And then we get more into that lab portion of the class, which is Unit 3, and that's Biochem. And we'll get into basics of DNA. I'll teach them some lab skills on different types of pipettes. And we do this thing called genetic transformation, and in a nutshell what we do is we change. This is E. coli on a petri dish. It's white. E. coli on a petri dish, normally E. coli, I shine a black light on it and it wouldn't do anything. It would just be, it wouldn't reflect the light and glow. Well, what we do is we genetically modify it so that it will actually shine this green color under a black light. And that what it's doing is there's a protein called the green fluorescent protein. They're pretty unique in their name of that, and that's what's causing that. So what they do, where the application of that is, that technology is that's how they make insulin. Instead of making a green fluorescent protein, they're making it a protein called insulin. And so then that gets into, well, how would you get rid of all the E. coli stuff and just get insulin? Well, we're doing with GFP so we can see it. So this is end result of protein purification. You end up with a little test tube of purified GFP, and they do that through this thing called the Hick chromatography. And then we do Pcr and Electrophoresis. In a nutshell, it's laboratory methods that you can take, for example, a little drop of blood, say found at a crime scene, not enough DNA to actually say it's from John Doe. What you have to do is, first of all, make enough copies of DNA that's in that sample of blood, which you can do in the lab, and you use this thing called a PCR. That's what they look like. That's the equipment. That doesn't show the chemicals part of it. And then you go from there, and then you do electrophoresis, which is this kind of equipment here. And what you do with electrophoresis is you do something like this. This is a result of electrophoresis. These are called gels, and students will know all about this. I'm circling what would be standards. This is like has all three. You can barely see those lines. That's a standard. It's called a ladder. This is saying that the person would be negative for PV92. They have PV92. This one here would be both mom and dad had PV92. That was me, and then that was my neighbor, and so we met that standard. These, this was, I think, if I remember right, I had this insertion in my 16th chromosome. It's called PV92, which means that I remember right that I was more like Eastern European or something like that. It just actually just tells you like, did your history come more from like Asia or Europe area? It's kind of interesting, or Africa, I think it was. I forget. It doesn't mean a whole lot as far as family history. It just gives you like some generic feeling of where you may have had your ancestors come from. And then there's CSI. We do who committed the crime, actually, where I give the students samples from a crime scene of fake samples, don't get me wrong. And then they have to run the PCR electrophoresis and say, okay, it was John Doe that killed that person. We do a pathogen outbreak. That's pretty cool. Students really like that. Just like you hear on the news, where last year the thing going on in Europe where people were getting sick. Kind of a different spin, but it's a story, and the students have to follow along and do some troubleshooting to figure out what caused this pathogen outbreak. And then we get into forensics, and we do that with a police officer. And so what would we find at a crime scene, and understand all that. And then Unit 4, I'm just going to touch upon the big one. We do this thing with yeast. Here's a little picture of students doing it last year. And basically their goal is to, I give them yeast, sugar, water, and some lab supplies, and I say, I want you to maximize the amount of yeast that you can make in 20 minutes. I give them some constraints, and then I say, have fun, and I just sit back, and it's really interesting to watch how they apply their research skills, their lab skills, and I obviously pop in and help them out as before they go down a completely wrong road. They do here phytoengineering and bioremediation. We might get into, probably not, usually there's not enough time for those. We hit on the highlights on them. And then Unit 5 is biomed. We do a research project on medical projects that failed, and we go into basic anatomy, and I use some well, I guess it makes it sound bad, but they're really very educational. They're games that are on the internet that your student you'll probably see them doing at home when we're on to biomed. They're the best way to memorize something very boring, which is the bones and the muscles of the body. So it's a really engaging way for the even for me. It sucks you in this game. It's a ball, but it gets the kids to understand muscles and bones. And why they have to do that is we go on an orthopedic implant project, and ultimately they need to be able to understand. Okay, so if I'm getting my shoulder replaced, what bones would they be dealing with, and then what muscles would they have to be working around, or would they be cutting, that type of thing. And they do, shoulders, knees, hips. Maybe this year we'll do a hand or something like that, because we've got a big group. Then we go into Imaging 101. The idea of building off orthopedic implants is, well, how do they size that implant for you before they cut you open? And so we'll tour the surgical hospital after I teach them the basics of imaging. X-rays, MRIs, CT scans, etc. And then we do a Cardio 101, where we basically are looking at anatomy and physiology of the heart, basics, not going super deep. And we do a little thing where we look at how students respond differently to exercise. And everyone runs in place for like 1 minute, and then we see how people recover, their recovery times, and compare someone like myself. I'm an older person, but I'm an athlete, versus someone that's an athlete, but obviously a teenager, and then compare that to a person that's a teenager but not overly active. And the students learn quite a bit from that, and it's quite interesting to see the responses. So that basically covers the year. It's the ball. I hope your son or daughter like it, and I hope this was a helpful video. It gives you a feel for what we do. I never have enough time to go through all this during an open house. Thank you very much.